All right, David, over to you. I'm here behind the scenes if you need me. Otherwise, take it away.
Great. Thanks, Marielle. And again, appreciate everybody taking your time out of your busy schedules to be here. Hopefully, we'll be able to get at least one or two nuggets out of this. If you're looking to replace a cooling tower or need to install a cooling tower, hopefully, again, we'll get some information. So, what are we going to talk about today? Well, there we go. We're going to go over a number of things. First, we're going to talk about what is a cooling tower, kind of back to the basics. Different types of cooling towers that are out there are available. We'll spend a very short time on that. Why do we need to replace the cooling tower? Then what are the steps involved in replacing your cooling tower? Talking about feasibility study, figuring out what do we need to do and how. Taking all that information, putting it together in construction documents, then taking those construction documents and sending them out to bid, and then finally actually getting the construction project moving forward. One of the things that I like to tell people at this point, as you're thinking about cooling tower projects, this is not like replacing, an AC unit in an individual unit. This type of equipment that's necessary and the planning that goes into this is not something that just happens in a day or two or even a month or two. This is a project you should be looking out literally 12 to 18 months. There's a lot of preparation. The delivery time alone for the equipment can be as long as 8 to 12 weeks. That's from just from the time that it's released and said yes, everything's approved, to it actually showing up on site. So it's definitely one of the things that I want to come across on this is to have that understanding of this is going to be a much longer type of a project. So then finally, again, but we have all that planning done, we get everything done. Then what happens? We're going to talk about mobilization, how to plan before the day it actually happens. Because typically, cooling tower, the actual construction itself of taking the tower off and putting it back on is relatively short. We'll talk a little bit about that. Then some lessons learned, some things to think about. What type of cooling tower is right for me? Not only whether it's open or open or closed loop, which we'll talk about, but the type of tower. There's different towers out there that are fiberglass towers, there's stainless steel towers. What are some things to think about as we move forward? And we'll go into that. So diving right in, what is a cooling tower? Oh, typically a piece of equipment setting up on the roof, although sometimes you will see them on the ground. So it takes water always flowing through the tower and air flowing through it as well. And as the water cascades down, so it basically drops it out. And as the water cascades down, either air will come up through, and again, depending upon the type of cooling tower, through or an open tower through evaporation, we will bring the water temperature down. So typically here in South Florida, we like to see, we design on water coming in at about 95 degrees from our building and leaving at about 85 degrees. That's typically what we see with cooling tower designs here. So the big thing is a cooling tower is the mechanism by which we ultimately reject heat from our building. We'll briefly go over this because for most associations, you're going to use an open cooling tower. But for various applications, like a closed, a lot of times we use those for processing equipment on like a chemical refinery or a brewery or something like that. But we do occasionally see these out there in the wild as well, but not a lot of times at condominiums. So, but it's good to know that when we say cooling tower, there's a number of types of cooling towers we're talking about. In addition to the way the water is evaporated, there's also different types of cooling towers in regards to what the material it's made out of. Here in South Florida, there's a case to be made for using fiberglass towers because of the corrosion. But on the other hand, using stainless steel towers or traditional towers is not uncommon and is still an appropriate response. But there's a lot of things to talk to your engineer about because there are drawbacks to both. Obviously, the steel system tends to rust more. but there are other issues with the fiberglass towers that come out as well. And that's very some site specific. So those are things as you're talking with your engineer about what to do and what kind of towers to use. Typically, we will take a certain type tower off and basically put the same type tower in. That makes it easier. Plus, it's been functioning. But those are things that you should think about while you're planning the process. So then that raises the question, why would I want to replace my cooling tower? Well, for some of you, you probably already know the answer to that, which, number 2 on the slide here, increased maintenance cost. Towers are like any other piece of equipment, just like your car. It eventually wears out. It eventually has to be replaced. And so, mechanical systems are the same. If we start getting a lot of cost to increase for replacing fans, replacing blades, replacing other parts of the tower. That said, replacement is not always the only option. As a matter of fact, sometimes replacement is not an option for some select condominiums. And again, this is something you have to talk to your engineer about. So therefore, you have to start making replacements. And it's still a good idea to bring in an engineer at that point to kind of see, what are our options. And again, we'll talk a little bit more about that during the feasibility study. But again, as towers age, another reason to change them out is, with wear and tear, decreased efficiency. We're starting to use more energy. We're not getting the cooling that we want because things are wearing. That kind of goes hand in hand with your safety concerns, but more. We're starting to get more microbial growth and those kind of things just because the system's aging. And for some of you out there, typically when I give these presentations, there's usually a handful of folks out there that's say, I don't have a cooling tower currently. We use a well system, which is fairly common here in South Florida back in the 50s and 60s, but have become less and less common as environmental concerns don't allow us to drill new wells. So for some of you, you're sitting going, well, I'm using wells now, but I'm being told that I can't continue to use them either for environmental reasons or because they're starting to fail. And when the well fails, I can't do anything more with it. So that's another, whether you're replacing a cooling tower or you're replacing a well system that functions as your cooling tower now, a lot of the steps in the process are very much the same. So what are the steps? The first steps is to engage an engineer to come in and do a feasibility study. Take a look at what is the tower currently. We'll cover that a little bit more depth in the next slide or two. Then after we do the feasibility study, we need to take our results from that, prepare the construction documents. These are the documents that will tell the contractors, this is what we want you to do. This is what we want you to replace it with. There's usually in those construction documents things as well detailing, hopefully, whether we need a temporary tower or not, or at least providing an option for a temporary tower, detailing out things like how long the contractor anticipates the building being without cooling. So again, preparing those that'll be able to go out to bid, and we'll talk again more in depth in the next couple slides. Then we go out and we select the contractor for bidding. Then after we engage the contractor, we start the planning process and construction administration. So we finally start moving forward. And again, so this takes a bit of time. There's a lot of site planning that needs to happen. So again, we'll talk about that in a few slides. So starting out first step, feasibility study. In some of it, we can, at the bottom, we can kind of skip a report for some towers. And some towers is, you just know, I don't need a feasibility study to tell me that I need to replace my tower. So on occasion, we will not provide a report, but the other items, the feasibility study itself is still critical to do, because that's when I go out and I get information as to your existing site. So I document not only, what is the existing cooling tower. Most of the time, I'm able to get data information off of tags that are on there. But sometimes the tag is so badly worn, the tower is so old that I have to start doing other things, taking measuring pipe sizes and things like that. Other clues as to tower sizing. Then I also, at that same time, I review the existing steel and concrete structure. When I replace rooftop units, which is kind of outside of the scope of this, but a very similar process, a lot of times the existing steel and concrete, I can figure out a way to use it without a significant amount of work. I have a lot more flexibility in a rooftop unit and in equipment selection. The components that I put in the rooftop unit, I can really kind of play with the weight, and that's where I'm going, is the weight. So there's a code requirement that says that if I'm more than, I believe it's 5% over my existing weights, that I need to have a structural engineer review and design the connections. For a cooling tower, unfortunately, over the last few years, some of the codes have changed and our wind loading on our equipment has gone up. And cooling towers, they're giant boxes typically sitting on your roof, subject to a lot of stress. Plus, we're putting literally thousands of gallons of water in your basin just sitting there. And so frequently, that's something else that needs to take into consideration is what do we have to do with the structure? But at the proposal stage, we can't really, we really don't know because we don't know what the existing structure is. So it's at this stage that we're able to finally start designing that scope for the structural. But again, the feasibility study allows us to see what exactly exists so that we can take that to the design process. For those that aren't sure of what your tower looks like, this feasibility study also will allow you to get that information and prepare a report that says, based on our findings, the tower has 3 years left, 5 years, or this is something you're already starting to see damage with now. You really need to start working on this project immediately. So that's kind of what the report will do for you. So one of the other considerations that a feasibility study will look at is whether the system is a closed system or an open system. Modernly, look on the slide to the left, we have a closed system. This is typically what we see in the newer builds. If you were to go, for example, where I'm setting now, I'm about 2 miles away or a mile away from the coast where they're putting up a brand new condominium. I guarantee you, if I were to go in there, the design's going to be a closed loop. So by closed, what we mean is we have a cooling tower that circulates through a heat exchanger, and that's all that it serves, is that heat exchanger. That heat exchanger today, and typically, is a plate and frame heat exchanger. So we can take that heat exchanger apart and clean it, because another name for cooling tower is air filter. So everything, dirt and debris that's in the air, they suck in and they drop into that system. And so that's something that in the design process, we'll talk a little bit more about, is thinking about filtration systems, basin sweeps, those kind of things, depending upon where you are, may be necessary. So again, something necessary to talk to your engineer about. On the other hand, buildings that were built in the 70s, 80s, perhaps even into the 90s, were built on an open system. So you can see on the right side here of an open system where we have water coming from the cooling tower and it goes down into each individual air conditioning unit and back up into the cooling tower. So the problem with this is, like I was talking about now, instead of keeping all that dirt and debris up on the roof or in the heat exchanger, now it's spread throughout your system. Unfortunately, a lot of times we can't change from open to closed because of structural limitations. But again, this is what the feasibility study will help us determine. For example, the heat exchangers, just one thing that we have to look into account. It's not abnormal for those heat exchangers themselves to weigh thousands upon thousands of pounds, something that a roof may or may not be able to take care of. So the other side of it is we need additional pumps for a closed side versus an open. And sometimes the electrical system just can't support. So while ideally it'd be great to switch from an open system to a closed for maintenance reasons and efficiency reasons. Sometimes it's not possible, but it's always something worth at least a quick look at. So now we're done with our feasibility study. What next? We take that information that we've learned from there, the dimensions we've got, the piping layouts, so forth, come back into the office and we start figuring out, we do a load to make sure that, this isn't a cooling tower that's been replaced 3 or 4 times, and every time they've increased the size, and now you're spending more money. So we want to take a look at exactly what does the building need. Sometimes that can be difficult to do because it's hard to find drawings, especially for older buildings. Newer buildings, we have a little more confidence that we know that if we're doing the first change out, we know what the equipment size is there and what's working. And again, this is part of the design process. Perhaps since the building was new, you've added load. That's something that we would need to take a look at as well to make sure that we're getting the right size. And once we have the equipment selected for predominantly the cooling tower, and one of the other things that we look at when you're doing replacements is, do we need to replace the pumps along with it? So again, back in that feasibility study, we'll take a look at that. If you've replaced the pumps 3 years ago, it may not make sense at all to, or it does not make sense to replace them now. On the other hand, if the pumps that are in there are the original pumps as well, it's probably time to maybe take a look at the changing those pumps out at the same time we're changing the cooling towers. And that way you have one time that you're down, everything's taken care of, and you have a relatively new system from the get-go. So once all of that design work is done, we'll put together construction documents. Construction documents will detail the plans, the schedules, details. We'll put them there, how we want the tower to operate, because this is also a time where we've allowed to make some changes where, especially here in South Florida, where we may have some temperate time where we don't really want the tower to cool the water because we want the slight bit of heat that we have that the building has to maintain. But the old design required to go through the tower, we might be able to say, hey, this is a time that we can actually put in a bypass and during those and change the sequence of operation so that during that times we can actually bypass the tower and maintain the heat in the buildings. Again, we're looking at the electrical plans, making sure that the existing electrical infrastructure, typically when we replace cooling towers, usually the existing electrical infrastructure is sufficient to handle it, but there are times that it doesn't. The big one during the design process, believe it or not, is again the structural plans. On a cooling tower, as I've said before, it's very difficult at times to stay within that 5% limit. And so sometimes, again, our structural teams literally will need to understand how the entire structure of the building works all the way to the foundation. That's not always that case, but a lot of times with cooling towers, we need to figure out how we're going to structurally support this. This would be a point as well. I mentioned earlier that maybe some of you are here because you're replacing a well. Wells aren't up on the roof. They don't have a lot of weight. And so as part of the design process, preparing construction documents, one of the things that we would also need to go through is the roof a good location to be able to put a new cooling tower? Can it take it? Was it designed for that kind of load? Or do we have to find an alternative space somewhere on the ground, carve something out somewhere, and that leads to a lot of things. If you put it on the ground, depending upon, again, the municipality you're in, you're going to have to get zoning approval, you're going to have to get approval of the plans, maybe you have to do screening. So there's a lot of things that go into it. If you're even more so, if you're replacing a well system and wanting to look at putting in a cooling tower. But at the end of the day, the construction documents are put together, ready to go out to bid for the contractor, and also ready to submit to the municipality for pulling permits. So after all that's done, the next process is very typical to any project you're going to do. go out and invite a number of contractors to bid on the process. Generally, like other construction projects, we want to see them being licensed, insured. One of the things the association could look at as well is bonding. Not every association chooses to bond, but it's always my recommendation to make sure that you're working with a company that at least can be bonded. That way it helps understanding their financial abilities. Again, you're going to want to see a list of references, knowing what subcontractors they're going to use, and warranties, because you can have the best warranty in the world, but if the contractor is not around or the provider is not around to service that warranty, it's of no value. So after we get the bid process set up, we get it sent out to a few folks. The engineer should also go out on site now and walk through with the contractors, so the contractor can get an idea of exactly what's going to happen on the site. Everything from the picture that's on the screen now, we were able to use a crane. We have another project ongoing right now where we're going to have to use a helicopter. And so these are things that the pre-bid walkthrough will be able to tell the contractors. These are things, how are we going to get it up there? What's the shutdown going to look like? How long is it going to take? Then after we receive all of the bids, the engineer, again, in coordination with the association, with the engineer, should look at negotiating with the selected contractor and start walking through the scope and making sure all the scope is covered. And then you select the contractor, engage them with the contract, and then we're off to the races. So pre-construction, again, for a cooling tower project, potentially is more critical because this is the cooling for your building. There may be a handful of common areas that have other type of cooling, but for the most part, when your cooling towers are down, your AC system is down. And so that's one of the things we really want to work on: planning shutdowns, making sure we have everything on site, so that when we do that shutdown, we can get the shutdown done in the minimal amount of time and get the AC back on. Sometimes, again, during the pre-planning process, we realize that there's no way we can do this in less than a day shutdown. So this is another time we're going to be talking about, do we install a temporary tower and run off of a temporary tower to give us more time to be able to actually do the change out of the existing cooling tower. And again, those are things that will be talked about well before the construction administration stage. But this is where kind of the rubber meets the road, that we need to start planning for. Where are we putting that temporary tower if we're going to use one? How are we going to pipe it up to make sure it's running right? How long do we anticipate having it there? So those are some things to look at. Then finally, the day comes, or days come, weeks, the week comes. Because typically a cooling tower changeover is going to be no more than a week, but again, depends, very site specific. Some can be done shorter than that. Some may take longer. During the process, the engineer, if the contractor has questions, the engineer should be answering those questions. One of the first things to come out of the pre-construction is one of the very first submittals should be that cooling tower and pumps, because those are the two long lead time items. Getting those done, submitted, and released to the factory so we can start that ticking to the clock to when we get those on site. So again, contractor, though, typically during this process is going to be on site doing some other things that don't require shutdowns. Maybe they'll install piping. We're going to put in a bypass that we talked about earlier. Maybe they'll go in and do that, and that doesn't need a shutdown. But definitely, like I said, pre-mobilization. This is where finally basically the day has come. We're gonna shut the building down. So we want to make sure that we're ready. So the pre-mobilization preparations, I guess I got ahead of myself a little bit on the slide. I apologize for that, but again, this is the things we were talking about in the last slide. Communication, very critical. making sure all the equipment is there on site so that we're not shutting something down and going, oh, we need this piece of equipment. But during that pre-mobilization, having conversations with the contractor in coordination with the associations to make sure, everything's there, everything's ready, time to go. When you change out a cooling tower, there are a number of stakeholders that need to be involved. First one that jumps out, the authority having jurisdiction, the local municipalities. You need to have the permits. They're going to want to do inspections, make sure everything's okay. You are, of course, certainly the contractor and any subcontractors. This typically would also involve the engineer. It needs to be making sure that you have right timelines, who's responsible for what. Your facility maintenance team, your building engineer, are very critical as well, because that person typically has a lot of corporate knowledge, has been running the existing tower, so they know how it operates. So a lot of times they can help with the shutdown to make it happen in a much faster time, because they're aware of how the system operates now and how it's going to respond when we do certain things. And last but not least, the board members hopefully have been involved kind of from the very beginning. So it really leads to unit owners and making sure that unit owners have the right expectation. They know when the shutdowns are going to happen. They understand what it's going to impact, because when we do a shutdown, a lot of times, again, we're going to have to go back through every individual unit and make sure they're off. And then when we restart the system, we need to go through and make sure every one of those gets started back up again. And so we're really having to work with the individual unit owners to make sure that they understand that process and what's going on and what's needed. So again, very similar to pretty much any type of construction project that you have out there. And so finally, the day comes, and the pictures across the top of your screen there is actually from a project that we did. You can see that, again, we've got everything on site. The towers are already there setting in the parking lot. Our pumps are setting in the parking lot. Our piping spool pieces are setting there. And cranes ready to go. So we're ready. And again, this is where all the planning comes together to minimize the disruption to the property. All of that pre-planning, everything comes together on this day or two where we're doing the lifts. The typical day, again, we arrive, safety briefings, very important. There's a lot of moving pieces, a lot of things flying on a day. My background is actually predominantly in mechanical contracting. So I personally have been on a lot of job sites where we've changed out cooling towers. So we really need to pay attention, make sure everybody's paying attention, and everybody goes home at the end of the day. And more importantly, everybody understands, just as important, I should say, because it's very important, everybody goes home at the end of the day. Everybody understands their role so that everything can go off smoothly. Then we get all of our equipment set up, ready to go, staged. Then we do our actual lift. Then after we're done, another thing that's important is to make sure we get everything cleaned up, ready to go. This again is typically covered in our plans and specifications. But again, a lot of times cooling towers are on the roofs, so we've got to think about how are we going to lift the debris off, how are we going to get stuff cleaned up, making sure that we dispose of it properly. So some things to think about. Talk about what tower is right for me. We live in paradise. Unfortunately, the price of paradise is that we live in a very moist environment. So anything that's steel will tend to corrode. So we need to think about even something as simple as what are we going to use for our door latches? What are we using for our fan blades? And these are things you would need to talk to your engineer about. Typically, the type of tower, whether it's a crossflow or counterflow, But those are things that need to be taken into consideration because they operate differently. And so that's where on a counterflow, the water flows one direction and the air flows the other. On a cross flow, the water flows down, the air flows across. Um, there are things that with each of those that could be different. And so typically a lot of times we'll replace like for like. But there are reasons to change. And again, those are things to think about, talk through during the design process. What's most important, or what's good for our particular application. Again, the open and close is always worth looking at least at a quick 30,000 foot level to see if it's an even possibility, because it's definitely an improvement to the system. But again, a lot of times the structural or electrical just prohibits that from happening. And then, as I talked about multiple times, cooling towers frequently will require changes and modifications to the structures holding them. As the codes have increased, wind loading has increased. That has increased the loads, if you will, on the supports that are required to hold. So while it may have been fine 30 years ago, even 20 years ago, it's not today because our wind load speeds have increased under current code. So that's something that really needs to be looked at. It's something that could be the big issue. Again, that's flushed out a lot during the design process. And then one of the big questions is, how long am I going to be without cooling? So I said, typically, this cooling tower is your air conditioning. So without it, you do not have any air conditioning in the building. A lot of times we can do shutdowns. I've got a new cooling tower project that I'm involved with at the moment. The contractor has done a lot of amazing work. I've managed to get that shut down to literally 4 hours. There's a lot of unique things involved in that, but we're going to do the shutdown early in the morning, and there's probably a good chance that unit owners, other than the fact that we're resetting their units, are probably never even going to know that it happened. On the other hand, I was involved in another project in the past couple of years. We literally had the cooling tower down for about 2 weeks. And so we had to have a temporary cooling tower setting on site. And a lot of it had to do with redoing the structural steel. Yet another one that I've been involved with, their well failed. And as a result, they had to bring in a temporary tower and necessarily kind of abbreviate everything that we've talked about today. Again, the big thing to take away from everything, I do want to comment on here that it shows hyperlink to cooling tower video. I would love to be able to show you the video we have. We got about a 2-minute video. Unfortunately, right before we were trying to go through this, we ran into some technical issues. So I would rather not show it to you than to show it to you poorly. So as a result of that, anybody that's here, I believe Mariel has your email. We're going to send that video out by way of email. So that way it looks and sounds the way that it should. So that way you're not worried about it not being on right on your side, and that's so we'll make sure that you get that to you. So I'm going to flip through this real quickly, maybe. I think we kind of wrapped it up a little bit quick. I don't know, Mara, do we have any questions in the chat?
We do have a few questions, and before we get into the questions, I'm just going to go ahead and place the evaluation link into the chat. So again, if you guys haven't already clicked that chat button on the bottom of your screen, go ahead and do so now. And I'm going to place that.
So if I could just do some closing remarks, I guess, Mariel, again, the biggest thing that I want you to get from this presentation is this is not going to be a short-term project. This is something definitely requires planning, requires things being thought out. It's not going to be, oh, hey, we need to replace our cooling tower. Can you be on site, next month and get it done? You know, it's a lot more involved with that.
Thanks, David. Before we get into the couple questions that we have, I just want to let everyone know in the chat, you should see the link to the evaluation form. Once you fill out the evaluation form, upon submitting, you will have an opportunity to have access to David's contact information, in which case, if you do want access to the slides or you want to be sent the slides, you can contact David directly to get those slides. You'll also have a direct link to our upcoming webinars for the next few weeks, and a link to the Falcon site. This session is also being recorded, so if you guys want to rewatch it or you want to share with your board, your community, your colleagues, you'll have an opportunity to do so on the acebytsk.com website. I'll go ahead and put that link in the chat as well. Next week we're going to be here. Usually we're here at 11 a.m., but next week will be 2 p.m. So for anybody who's joining us next Wednesday, we'll be here at 2 p.m. online. When we have a few more questions entering. Oh, I don't see the link. Okay, guys, please go ahead and click the chat button on the bottom of your screen. If you do not have the chat button open, you will not see the link come through. Okay, I'm gonna put it back in there right now. I'm gonna send it again. I'll send it again even in a few minutes when we're done answering questions. So don't worry about that. But with that, let's answer a couple of these questions. So let's start with the first one from Karen. How long should a cooling tower last, and how do you know when you need a new one?
Good question. So typically, we look to see the cooling towers are about a 20 to 25 year life expectancy. And again, there's a lot of things that could go into impacting that. How close you are to the ocean. A cooling tower, for example, in Orlando is going to last a lot longer than a cooling tower in South Beach. Generally, you know when to replace it, very similar to any other mechanical equipment.
You take care, buddy. Thank you.
Any other mechanical piece of equipment that when you start paying a lot more for maintenance, or you start seeing performance falling off, that's a time to start looking at it. And certainly if you have a tower that's 20, 25 years old, it's probably worth having someone come in and take a look at it just to kind of plan out for when you may need to replace it. But that's kind of the general rule of thumb. I've seen cooling towers last less than that. Certainly, if they get hit by a hurricane, that's one where the tower didn't need to be immediately replaced, but we're actually working on replacing the tower right now. From the last hurricane that hit us, I think it was back in Irving. I think it was the last. So it's been a few years, but that's definitely when you want to see it. If you go up and you're seeing water leak down onto your roof, and there's a lot of corrosion, and the basins are just not holding water, that would be probably beyond time to start looking at replacement.
We have a few of this similar question here. So, what is the estimated lifespan of a cooling tower equipment? Another one I have 25-year-old Marley towers. Are they near replacement? So I don't know if there's anything different in here that you want to touch on.
Now, just again to reiterate, though, again, just because it's 25 years old doesn't mean that it's necessarily time to wholesale rip it out and replace it, because again, a lot of it depends upon the maintenance that has happened. There's materials on the side of the cooling towers that we use for the evaporation called fills. You can actually replace the fills, replace the motors, replace fan blades. There's a lot of things that we could do to keep the tower running. Usually it's just when the box itself starts falling apart that then we really can't do much with it, and we have to kind of replace the box. But again, a lot of that is somewhat of it is a board approach. Do we want to be proactive, and then we don't have to worry about doing heavy maintenance for a number of years, or do we want to I've worked with associations where we just kept replacing everything. We were able to keep the towers running for a very long period of time. So at 25 years, I would ask the question. I go out, first step is go out and take a look at them. What do they look like? Do they look like a piece of equipment that needs to be replaced? A lot of corrosion, a lot of leaking, water's everywhere. Or do they look like, they're running tight? I really don't see much in the way of corrosion, water stain in the basin. Then you probably could look at getting a number more years out of those Marley towers.
Excellent. Is this considered a reserve item?
Yeah, that is a more difficult question than what you might be able to understand. I mean, it is a capital reserve item for sure. I don't believe that they have mechanical. And I apologize, I wasn't prepared for the question, although I was literally just looking at structural integrity reserve studies this morning and some statutes surrounding that. But I don't believe they're required as part of the SERS, but they would be something that would be in your capital reserve. And typically it is something that associations reserve for.
Perfect. Another one, what is the standard life expectancy of a cooling tower? Should properties plan for refurbishment at some point during cooling tower's life?
A lot of it depends upon the size of the tower. Some of the very large buildings that have towers that are several hundred tons, refurbishment is a good idea. It's not a bad idea as well. At some point before the end of its life, typically the fills, which again they're fiberglass plastic materials typically on the side. A lot of times those get very kind of gunked up, if you will, with mold and mildew and just junk. Like I said, that's kind of where a lot of the filter of the water hits as well. So a lot of times we'll replace that. It's not abnormal to replace the fan motors that are in the towers themselves, but typically for a 80 to 120 ton cooling tower, we usually cover those types of things through a maintenance approach, and generally don't look at doing a full rebuild. But it's certainly another approach that the board could look at and talk to either an engineer or a service contractor to decide, what would be a good approach for that specific application.
The next one is there a ballpark cost per ton to estimate for cooling tower replacement?
Yes. As you get into the higher tons, it actually, the cost per ton goes down. To the smaller ones, the cost per ton goes up. But I'm seeing, a typical, I'm trying to think, the last bid that we had was, I believe, 150 ton unit that we were needing to use. I think that one probably wouldn't be right because we're using a helicopter. The one before that we're able to use a crane on is typically going to run, 200,000, 250,000. Again, so much of it is very specific, but that's for 150 ton. So, we're talking maybe $1,200 a ton, if I'm doing my quick math right.
Okay, excellent. How many days will a cooling tower need to be shut down for the installation of cooling tower pumps?
Again, I'm starting to feel like an attorney. It depends. If it depends on if I have two pumps already, and each pump can handle the load. So say we're doing this in February, and we don't need as much out of our cooling tower. There, I can actually sometimes get away with replacing pumps without even shutting the system down. On the other hand, if I have a setup where I only have one pump and I'm not installing as part of the project a secondary pump, we typically would like to be able to do that at the same time we're lifting the cooling tower. So we would have hopefully get the contractor to have one crew working on the pumps and one crew working on the tower itself, and be able to do both of those, within 1 to 2 day shutdown. But again, a lot of it is unfortunately very site specific.
Okay, from Patrice, our cooling tower is located on the ground behind the condo. Would a fiberglass or steel tower be best? Current tower is rusting out.
And I'm trying to be careful with recommendations, because I don't want to get yelled at by one cooling tower manufacturer or the other, because there's great reasons to use all of the products that are out there. From a rust perspective, certainly the fiberglass tower, where we're at, has an advantage. Although I've seen, engineers specify fiberglass towers and then galvanized hardware, so it really kind of defeats the purpose of the long lasting. On the other hand, there are things that we could do for a traditional tower that, maintenance on it, making sure that when we see rust spots that we clean them up, and just keeping things clean at the traditional. If you're in an area where you're literally at the beach, talking with the engineer, but my personal preference, I do like looking at the fiberglass towers under those circumstances, but there are sometimes a couple other factors that we need to look at, like water. I've had issues where, again, the fiberglass towers, water flow, water carryover, if you will, out of the tower itself becomes an issue. It's a little more probably beyond the scope of this particular presentation, but other than to say that there are good things for both. But if you're right there on the coast, it would definitely be worth a serious think and thought about the fiberglass towers.
Thank you. What's the average price of a temporary tower, let's say for a 200 unit property?
Honestly, Mary, on that one, unfortunately, I don't know off the top of my head, and I would hate to
reason to reach out to David offline. Yeah, no, that's a great reason to reach out to David offline if you want to talk about that a little bit further.
Yeah, I mean, have reach out to me offline. I can look back at some of our past projects, but off the top of my head, I don't remember. But I'd be glad to look back at some of our past projects and some other contacts that we have to be able to give that information.
And now we have one from Jake. How much does a helicopter lift typically cost? A lot of cost questions. Makes sense. I get it.
That one I actually know, because it is stunning. And this is where, working together perhaps with your neighbors may even be a good thing to do. A typical helicopter lift is about $250,000 just for the lift. And so helicopters lift can be very, very expensive. Because in addition to all the other things that we've talked about that we have to coordinate, a lot of times we have to coordinate now with the FAA. If we're coming over a body of water, which we frequently do down here, we also have to coordinate with the Coast Guard. Our flight paths have to be clear, because they make it very clear if something happens to that helicopter, they're dropping the load and they don't care. So we have to make sure that should that happen, it doesn't land somewhere where it's going to cause loss of life. Plus, they are very expensive. I occasionally use a company out of St. Louis. I think there are some closer up in Georgia, but I don't believe there's any that are here local. So we're always having to pay mobilization fees to get them down here. The helicopter lifts can be very, very expensive.
Wow. Okay, good to know. All right, so could we contact you directly for a cooling tower replacement cost analysis so that we know the amount we are collecting is correct, or at least close to the amount needed?
Yes. Yeah. If other questions that come from this are very specific, feel free to reach out to me. Email is usually best, but we connect in a lot of other ways.
Excellent. So go ahead and grab David's email address, which is right on the screen. If you guys want to have a copy of the slides, please contact him directly. And again, you can always you can always find the recorded sessions within a day or two of the session on the acebytsk.com website. I did put in the chat a link to our upcoming webinars. Again, next week is going to be at 2 o'clock, 2 p.m. I also have the evaluation form in there. If you guys are not seeing the evaluation form for any reason, I'm going to put it in there one more time. And I'm going to stick around for just a couple minutes here to help you guys with any questions. You can now send me a direct message in the chat if you are having an issue, and I'll do my best to help you out. Upon submission of that form, you'll also have an opportunity to request contact from any of our great service providers, our experts, if you guys are struggling with something in particular in your communities. Other than that, I just want to say thank you so much to David. We really appreciate it. What an interesting and kind of niche topic that you get to highlight your expertise, and hopefully you'll have a lot of inquiries directly so people can learn a little bit more about their particular circumstances. We have one more question. Thank you. Thank you, Jill. Thanks for everybody for joining us. I hope to see you guys next Wednesday. Other than that, David and Mark will let you guys go.